All right, here we go. Let's take a look at the last free response here. This is the big dog. This is typically the one that students struggle the most on so far. Let's see if we can fix that though. So what are we looking at here? We're looking at a no calculator, no context problem. The main goal is to kind of rewrite and to solve expressions or equations, manipulate them a little bit. And we're only going to be looking at units 2 and 3, exponential, logs, trig, inverse trig, all that fun stuff right there. So just kind of a lot of rules we got to be able to use to manipulate things. So let's get after it, man. So here are the official directions. So I would make sure you read through these. At some point, you'll see them on the exam. We're going to go through them briefly here. Basically, the domain is all real numbers unless they tell you otherwise. So they're going to, and we always use radians. We're always doing that anyway. So just assume it's all real numbers unless they limit that domain somewhere in there. Bring it on down here to what are the solutions? If you can solve it without your calculator, go ahead and solve that bad boy. So it gives you a couple examples. A couple examples here. Don't leave that as log base 2 of 8. Why? Because you can rewrite 8 as 2 to the power of 3. And then with your little log rules, you can move the 3 in front. These bad boys, I guess, cancel when you move the 3 in front. And you can rewrite that as just 3. Cosine of pi over 2, you got to evaluate it. So if you have that, think your unit circle. Whoosh, we've been doing that all year, though, so you should be cool with that. Cosine of pi over 2, yeah, that's just 0. And same thing with your inverse trig function. So what's the arc sine or inverse sine of -1? Where does that happen? That happens at pi over 2 as well. So go ahead. That looks awful. I can't leave that there. Go ahead and make sure that you evaluate it if you can. Excellent. What else? Simplify it if you can. So maybe we can evaluate it down to a number, but clean it up. You have to clean it up. So we obviously 2x plus 3x is 5x. Same thing when we have the same base. So we're going to review these exponent rules. Same base, when you multiply, what do we do with the exponents? We add them. What do we do when we divide things with the same base? We subtract them. So make sure that we can do that. And then the last one is show all your work that leads up to that. All right, now the directions are out of the way. Let's talk about what's going to be on this bad boy. So you don't get a reference sheet. You don't get anything. There's nothing to look at. So make sure that you go back on your own, or not on your own, but like make sure you know all these rules here. Now, do you have to memorize all this? No, but these are things we should know. We should know how to rewrite rational exponents. We should be able to take a negative rational exponent and rewrite it as a fraction. Things like this. So lucky for you, I made a little review of all this. So if you're feeling a little rusty on this, it's been a while, go ahead, before you even watch the video, I would go to the packet, fire up those review problems. It'll show like it'll take all these exponent rules. Just look at my answers and it should like jog your memory on how to do them, or maybe you can do them. But do that first. Make sure you're really up to date on that, and that's cool. And then watch the video. If you're feeling good, let's just keep rolling. Also, your trig identities I threw in there. This is all fair game for our trig identities. Anything there we can use on any of these problems. All right, let's just do one, and then I'll give you some to practice to make sure you're cool, but we'll do one together. So the first part is usually solve. So we're going to solve. They always give you two equations. They're going to give you a g and an h. They're going to say, hey, g of x is this, h of x is this. Go ahead, set it up, and solve. So let's do that. So if I know the g of x is 3, come up here and set that bad boy equal to 3. So now we're looking at this thing, and again, it's all about, do we remember those rules? So I set it up. Sure, what do I do when I have x as an exponent? I got to get rid of it. What base am I going to do? I know I need to take a log to bring it down. I'm going to take log base e, which is the natural log. So I'm going to take the natural log of both sides. Whoosh, there it is right there. Love it. So why do I do that? Well, I don't know what the natural log of 3 is. That I'm stuck. Just going to leave them alone. But what happens here, I can bring down the exponent in front. So I can bring down that x minus 2 when I have the exponent here, and that leaves me with the natural log of e. And what is good, they're inverses. That's why I picked it. The natural log of e cancels out to just 1. So I'm really left with natural log of 3 of x minus 2. So that's how we get it down there. And now that's friendly. We don't like x as exponents. Now we can solve this bad boy. To get x by itself, I'm just going to add the 2 to both sides. And again, I'm showing all my steps so I don't lose any points, so they can follow everything I did to the answer right there. Oh, wait a minute, I almost got it wrong. Showing all those steps plus the 2, there we go, equals the x. So added 2 to both sides, showing all those steps. I got excited. There's my answer. Now don't go crazy here. I know we're supposed to simplify. I can't evaluate anymore. I don't know the natural log of 3. I can't combine these in any weird way. Just leave it. That's okay. You can have a weird looking answer. As long as you can't clean it up, that's a great answer. Fantastic. Let's try the other one. So now we go over to the h of x. So this other function here is going to equal 5 pi. And we're going to say, if you don't like arc cosine, you can use arc cosine. I'm going to switch it just so we know they're interchangeable to inverse cosine. It's the same thing. So make sure we're cool. Whatever one you like to work with, I don't care. I just want to use them both, so we're cool with both. And now we're going to solve it. So I'm trying to get x by itself. He's stuck inside this inverse trig function. So let's get him out, man. So just like any other old equation, we're going to divide by 6. Get this ball rolling. So we're looking at 5 pi over 6. These bad boys cancel, and I'm now got this inverse cosine or arc cosine of x over 4. Now, how do I get rid of an inverse cosine? You do his opposite. What's his opposite? It's cosine. So we're going to take the cosine of both sides, just like we took the natural log of both sides. No problem here. I'm going to take the cosine of this side. Well, this is going to be crazy. The cosine of the inverse cosine of x over 4. And why did I do that? So some things would cancel for me. So this cancels out this. It's like squaring a square root. They're just gone. What is the cosine of 5 pi over 6? So just, roughly get to that unit. Oh, I definitely went rough. Roughly get over to that unit circle. I know 5 pi is over 6 is over here. I'm in that negative positive quadrant. And I know 5 pi over 6 is going to give me radical 3 over 2. And because he's in this quadrant, he's going to be negative. So he's a negative radical 3 over 2. Awesome. Those cancel out to give you x over, ooh, that's a rough looking x. X over 4. And then let's just finish this off. I'm going to clean this up here. And I want to get x by itself, so I need to time both sides by 4. Come over here, times that by 4. Those are going to cancel. And I'm going to be left with negative 2 radical 3. That is a fantastic answer. I am good to go here. So I showed all my steps. I didn't go too crazy oversimplify. Got a nice answer. That's part A. We're just going to set it up and solve it using our rules. Love it. All right, let's take a look at part B. So this is the rewrite section. We're going to just kind of clean up an expression, make it look a little nicer, condense it usually, cancel out some things. So let's go ahead and do that. They give us two functions again. So we've got J and K this time. We're going to rewrite it, and it's going to tell you how it wants it. It wants this one as, let's underline that so we make sure we know our goal here. They want to write this in terms of cosine. So let's bring this bad boy down here. And can I rewrite it in terms of cosine? Sure. So now this is a trig one. We've got those trig identities. One of my favorite things to do is automatically turn tangent into what? He was going to be sine over cosine. So let's try that. So again, this is like little puzzles. Try it, see if it works. Sometimes you got to start over. But I've got a fraction and a fraction now. So that's actually good for us. So what does that equal? So that's going to equal, I can think of the sine of x is like the sine over 1. And I'm going to flip that second fraction because it's being divided. I'll write out the steps here. I don't know if you have to be this thorough, but I want to show you exactly what I'm doing. I'm dividing this by, oh, that looks terrible, sine of x, cosine x. So I've got a fraction and a fraction. I've got the, on bottom, this is like one fraction right here. And what does that mean? You're going to flip that bottom fraction and multiply. So I'm going to say, hey, the sine of x over 1 if you want, times, let's flip that over, I've got cosine x over sine x. And why is that good? Well, I'm going to go ahead and what happens here, I can cancel these bad boys out. And look at that, I am done. I've made that cosine x. Awesome. Very, very nice. So that's cool. Excellent. Let's try the next part here. So let's do it with logs. So you don't know what you're going to get. You're going to get a grab bag of exponentials, logs, trig, inverse trig, you're going to get it all. So it's going to be kind of a grab bag on what you get. Look at this monster here. So can I rewrite this bad boy here? So sure, they're all the same base, and I'm just adding them. So I look for, is there anything in front? So, yep, I got a half in front. So let's go ahead and, let's go ahead and rewrite it. So I'm going to show all my steps here. I want to make sure I get all my points. So I'm going to show everything I did. So the first thing I'm going to do, take that 1/2, I'm going to move him up and back as an exponent and see if that helps me at all. So it's still log base 10. I'm going to have x to the 4th to the 1/2. And then I'm going to say minus log base 10 of just 4x. So there's the first step. And if I really should have, like on the last one too, show what's going on here every time, rewrite what's going on to my function, the k of x. So now when I have this, can I clean it up a little bit? Yeah, this cleans up. A half of 4, this is a power rule. You can multiply them. So I'm even going to show that. Again, I'm going to, if I err on the side of showing extra steps, I will do that. Because I do not want the judges, not the judges, the scorers to think about like, hey, does this person know what they're really doing? Are they just skipping step? You know, that top one I could just said, hey, it equals cosine. I know I was heading that way anyway. But I cleaned that up, multi-power rule right there. Awesome. Then what's going on here? Well, now I can start combining things. So let's change over to green. What's going on in my function here? I know if I add, I multiply. If they have the same base, that means multiply. And if I subtract, I divide. So the goal here is log base 10. And some people flip out. So on this, on like, who comes first? Well, you just go left to right. It's, you know, we're just going to say what's going on here. I'm going to say, hey, I've got x minus 4. I'm going to times that by what? X squared. And then I'm going to divide it by 4x. So the order doesn't really matter on that stuff as long as you get in the right spot. Because we're multiplying and dividing with our, I know it's adding subtraction, but the rule is these you multiply, these you divide. It wouldn't matter where it is. The division's going bottom, multiplication goes on top. Okay, so what's going to go on for the next step here? So I'm going to say, hey, what can I do here? I'm going to go ahead and I can cancel this bad boy with one of these x's here. So again, I'm just going to show that I did that just to make sure everyone is cool with me doing that, showing that step. I'd rather show too many steps than not enough steps. All right, let's finish this bad boy off here. So what's going to happen next? I need to distribute this x into both of these. So my function k of x is going to look like this. So I've got log base 10, and I'm looking at x squared minus 4x all over 4. I think this is pretty good. I think this would get you full credit here. You've gone as far as you can. Just to show you another manipulation of it, you could actually rewrite that the divide by 4 as a fraction. You know, that's cool too. We can say it's 1/4 times all of this stuff too. So if you want to go even further, you can. But we've kind of gotten to the point where, yes, we've done some really good things. We've got this log base 10. So let's distribute that 1/4. So we're looking at really, this is 1/4 of x squared, 1/4 of that. The 4's cancel. I'm distributing again. Lots of distribution here. Now I'm definitely stuck. That's it. There's no way farther. Pretty sure you get full credit for this right here. This is even definitely full credit here. Just don't overdo it and make up rules that don't exist and things like that. The goal was log base 10 of an expression. I made it. I cleaned up as far as I could. We're good to go. Okay, so one thing you'll notice on the scoring rubrics of release questions or on the practice problems I have is that it will include a domain with this. Remember, fractions you can't divide by a 0. It's undefined. It's impossible. So, you know, we don't want tangent to be 0. So it'll put a little caveat up here and it'll say, hey, tangent is not allowed to be 0. Also, even dealing with tangent, the cosine value of tangent can't be 0 because if you divide by 0, tangent in itself would be undefined. So it'll include this domain. You don't need to include that. I just want you to freak out. We're not scoring that. You don't get a point for it. They don't look at it. But I don't want you to freak out if you see those kind of, hey, this domain over here. Same thing with logs. Remember, you can't log a negative. So I would look, these got to be positive values inside the parentheses. So they would say something like, hey, x has got to be greater than 4. Don't freak out if you see that and you're like, what? You don't need that. We're not going to score it. We're just scoring answers. Just make sure you know what you're shooting for. So I'm shooting for cosine. I was shooting for log base 10 of some expression. And then try to get there, and we're good to go. Awesome. Let's wrap this bad boy up with part C. Woo! I love it. I think this is my favorite. It's really solving, but they call it input-output values. So we're looking for, put something in, something comes out. So here are the input values of the domain are this. So we're going to set it up. So what is the output value? So if they give you the y value, so when does this monster equal radical 3? So I've got this going on right here. So set up like you're solving your equation. And then again, we're trying to solve for x here. So we're back to solving. So we're going to divide by -2, divide by -2. So we're looking at the negative square root of 3 over 2. Those bad boys cancel, and I've got sine of 2x. Awesome. So now can we solve that? So I'm stuck here. The sine of some angle. I don't know what the angle is, but the sine of that. So how do I get rid of sine? Yeah, I'm going to inverse sine this bad boy. So I'm going to take the inverse of negative radical 3 over 2. And I'm going to take the inverse. And again, I'm showing all those steps. The inverse sine of sine to get rid of that. And let me give myself some space here. And what's going to happen here? What is the inverse sine of radical 3 over 2? So I got to think back to, hey, where is sine negative? So if I think of all my quadrants, where's sine going to be negative? So there are all the signs of them. I'm looking at sine is negative in the third and fourth quadrant. So let's see if I can draw a little unit circle here. Woo! A little rough. And I'm looking at, so okay, I'm looking at sine's going to be negative over here and over here. So what are these angles? So let's do this one first here. So what makes a sine value of radical 3 over 2? So I'm looking at this 1/2 negative 3 radical 2. That is going to be, oh, we can name this however you want. It's going to be pi over 3. So do you want to call it negative pi over 3? Or you can call it, if we were trying to, pi over 3. Or if you want to call it a positive angle, we went all the way around the unit circle, but we didn't get quite back to where we started. So 2 pi would have been 6 pi over 3. So this will be 5 pi over 3. Awesome. So I'll use 5 pi over 3 if that's cool. So I'm going to use the positive one. So this is going to be 5 pi over 3 equals, these canceled out, equals 2x. But there's two places, right? Over here, the same thing. So if I'm pi over 3, that same pi over 3 distance past pi, so pi you can think of as, 3 pi over 3. That's just 1 pi. So add another one to it. I'm looking at 4 pi over 3. So I've got another answer here. 4 pi over 3 equals 2x. So I got to do them both. Don't just stop on one of them. We got to do them both. So right here, if you make it this far, you're in pretty good shape, man. So we're right there. What I like to do before I solve this is say, okay, now I can take care of any possible one. So if I'm talking about 5 pi over 3 and it happens a whole 360 degrees, I know not degrees, a whole circle, a whole 2 pi later, this is really 5 pi over 3 plus 2 pi n, where n is the number of times I go around. N is some integer here. And the same thing over here. So I've got 4 pi over 3 plus 2 pi n, where n is some integer, equals this 2x still. So the angle was 2x. Normally I'd be done. That's just x or theta. It's just an angle. But in this case, it's 2x. So what does that mean? Uh-oh. I got to solve for x. So what am I going to do? I'm going to divide both sides by 2. Divide both sides by 2. So what in the world? Let's get some room here. What is 5/3 divided by 2? If you want to write it out, you can. If you divide that by 2, you're multiplying it by 1/2. So what am I looking at? I'm looking at 5 pi over 6. Now this is going to cancel out this as well. So that's going to give me plus pi n. And that's going to equal x. And same thing over here. I'm going to divide both sides by 2. Divide both sides by 2. This becomes 4 pi over 6 plus pi n because the 2's cancel. And I'm going to put one big x out here if that's cool. Oh my gosh. X equals this. And it equals this. Both of these right here. If you want to reduce that second one and clean it up, we can. Let's go ahead and go for the glory. So I'm going to do something like this. And I'm going to have, what is that? 2 pi over 3 plus pi n. So it makes sense. So this was 2 pi n, which is like a normal period. Remember, this is the b term that messes up the period. Remember, this is going to give you that horizontal shrink in this case where it cuts it in half. It's going to happen twice as fast. You're shrinking it. So that's why that's happening. But think of it as just the angle, and you're solving it, and then you're cutting it in half. So how do they score this? Well, if you were able to correctly come up with 5 pi over 3 and 4 pi over 3, that would have gave you a point. Or 1 point for just getting the solutions, and then another point for putting the whole pi n with it, so getting all solutions. I should also say, hey, where n is an integer, that's just the number of times it goes around, and we are good to go. I love it. That's it. That is the tough one. That's one people have a hard time getting their points on. Good luck with these. Practice these. You'll get better at them. Good luck on that. Peace out.